Okay, so for the trig test, question 1 says find theta. Remember that theta is just an angle, and so it also says to round to the nearest hundredth. So what we need to do here is we need to figure out what sides they've given us. Remember that across from the box is always the hypotenuse. Across from theta is always the opposite. And then the last one has to be the adjacent side. Now we're going to use SOHCAHTOA here because that's pretty much what the beginning of this test is all about. So SOHCAHTOA. Now, when you look at the information that was given, there was no information given for this opposite side. So that means that we can't use any of the trig functions that contain an O. So that means sine is out and tangent is out. So to solve this problem, what we're going to have to do is we're going to have to take the cosine. So it's going to be the cosine of theta is equal to the adjacent on top of the hypotenuse. So it's going to be 9/13. Now this cosine, it's got a theta inside of it. So to get the theta out, what we're going to have to do here is we're going to have to take the inverse cosine. So I'll take the inverse cosine of this side, and then I'll take the inverse cosine of this side. So you can put this in parentheses if you'd like. Over here, these cosines, they cross each other out because they're inverses of each other. So then theta is equal to, and then we're going to go into our calculator. Now I'm going to change some settings on my calculator really quick. So let me go into the view just so that I can see everything that I need to see when I shrink this screen down a little bit. So edit all this stuff out and then shrink this. Oops. I need to shrink this thing down. So it's coming like this. There we go. So first thing I want to do, let me clear all this out. I want to go into my my setup and make sure that my degrees are in, or my angle is in degrees. And you can see right here where it says degrees. If it was in radians, that means that we have to plug in some pi's, but this doesn't have any pi's. So we have to make sure that it's in degrees. So we're good to go there. So we're going to hit shift cosine of 9/13. And it tells us that the angle is 46.186. We're rounding to the nearest hundredth. The hundredth is the 8, so we're going to go 46.19. There's our answer. Okay, the next one says solve the right triangle and then round to the nearest hundredth if needed. Now I'm going to be honest with you. The easiest answer to find in here is going to be angle L. And the reason why is because we already know that this guy right here is 90 degrees. And we also know that this one right here is a 48-degree angle. So we're going to use the fact that 48 plus 90 plus the remaining angle, which is angle L, has to add up to 180. So if we add all of this stuff up, this is going to be 138. So 138 plus angle L equals 180. And then I just have to subtract 138. So subtract 138 from here. So you could do that in the calculator. 180, take away 138. That means that angle L is 42 degrees. So angle L is 42. So we've got our answer for this one. Okay, now the measurements of KL and JK. So when we do this problem, we have to use our SOHCAHTOA stuff again. So the angle that we care about is 48 degrees. And so I already know that this is the hypotenuse. And this one right here is going to be the adjacent. So if I want to solve for that hypotenuse, all I would have to do is figure out which trig ratio I have to use. So it's going to be some old hippie, here we go, CAHTOA, SOHCAHTOA. Okay, so if I want to use the hypotenuse and the adjacent, hypotenuse and adjacent is going to be this guy right here. So in order to solve for JL, I'm going to have to set up the cosine of 48. and I'm going to have to set that equal to the adjacent on top of the hypotenuse. Now the adjacent is 5 and the hypotenuse, that's unknown, so I'm going to put that as x. So if I just put this over 1, I can cross multiply this. So I end up with x times the cosine of 48 equals 5, because 5 times 1 right here just gives me 5. Then I just have to take the problem and divide by the cosine of 48 to get x by itself. And at this point, it becomes calculator work. So we're going to do 5 over the cosine of 48. 7.47. So that's the hypotenuse. JL, forgot the number. It's going to be 7.47, and because the number after is a 2, I'm just going to cut it off. So JL is 7.47. Now at this point, because you now have two sides, you can actually use a squared plus b squared equals c squared, but I'm just going to do the I'm going to just do the other one. So this guy right here, this is going to be the opposite. And again, I'm just going to go ahead and use the adjacent because they gave me the nice number and it's a 5. So now I'm going to do the opposite over the adjacent. The opposite over the adjacent is the tangent. So I'll do the tangent of 48 is equal to the opposite over the adjacent. So I don't know the opposite, so I'll call that y. So I don't want to call it x because I already named the hypotenuse x. And then the adjacent side is 5. So again, you just put this over 1, cross multiply. So y times 1 is y. 5 times tangent 48 goes in the calculator. So 5 tangent, not 2 tangents, just 1. 48. 5.55. So what is that? KL is going to be 5.55. Now, if you were to do a squared plus b squared equals c squared, you should get something close to 5.55. And there is, I mean, you could get something just a little bit off because there is considered the rounding error. So as soon as you cut off numbers, it's not exact anymore, but it should be pretty close to 5.55. Okay, the next one says use the following diagram to find the exact value. When it says exact value, that just means the fractions. So they want us to set up the fractions for SOHCAHTOA. Now the only issue is we don't have this this missing side over here. So the first thing I would do is I would find the missing side, x, and because we have two numbers for the sides already, we could just do a squared plus b squared equals c squared. Now when you do a squared plus b squared, the a squared and the b squared have to be the two sides that create the 90-degree angle. Those are the legs of your triangle. So this would be x squared plus 4 squared equals 8 squared. So if I work this out, this is x squared plus 16 equals 64. And then I just have to subtract 16 from both sides. So we've got 64 take away 16. And that gives me 48. Now I don't want the answer to x squared, I just want the answer to x. So I'm going to square root both sides, and I'm going to leave this as a radical. So I'm going to type in the square root of 48. And that's going to be 4 square root 3. So now that we have that value, we can put 4 square root 3 in this place. So now to set up the 3 trig ratios, we've got to label our sides. So this is going to be your hypotenuse because it's across from the box. Then across from the theta, that's going to be opposite. And then the last one has to be the adjacent. And again, the fractions are SOHCAHTOA. So for the sign, it's opposite over adjacent. So the opposite side is 4 square root 3. The adjacent side is 4. Now, you should type these in the calculator, but I can kind of already see. If I have 4 square root of 3 over the 4, the two 4s are going to cancel. So this is going to simplify to the square root of 3. The cosine is going to be the adjacent side over the hypotenuse. So this is going to be 4 over 8 but again, you should always simplify these, so that's just going to be 1/2. And then the tangent is going to be the opposite on top of, I made a big mistake. Hold on, I need to go back a little bit. Let's go back to this one. The sine is the opposite on top of, so 4 square root 3, on top of the hypotenuse. I made a mistake and put it above the adjacent side. So that 4/8 is still going to reduce. 4/8, if you type this all in the calculator, is going to become square root of 3/2. Oh, good thing I caught that. The cosine was fine. The cosine was the adjacent on top of the hypotenuse, so 4/8 is 1/2. And then the final one is the opposite over the adjacent. So that's the one that gets the 4 square root 3 over the 4. So you cross those guys out, and then we've got square root 3 for our final answer. Okay, next, sketch the diagram, label all the parts with the given measurements, and then write an equation and solve it to the nearest foot. So when it says to the nearest foot is whole number. So it says a ladder 23 feet long is propped, let's get this out of my way, against your house, forming an angle of 37 degrees with the wall. So here's the wall, here's the ground, here's the ladder. So there's my 90-degree angle. The ladder is 23 feet long, so that has to be the hypotenuse. It forms an angle, so the ladder and the angle, or the ladder and the wall form the angle. So that means 37 has to go in this corner. How high? So how high is this one? Anytime you're doing how high, it's going to be the side that forms that 90-degree angle and goes straight up from it. So if we know this angle, this is our hypotenuse. This would be opposite, and this would be adjacent. The opposite side is no good to us, so when I do SOHCAHTOA, I need to eliminate anything that has an O in it. So that's gone and that's gone. So this is going to have to be the cosine of 37 is equal to the opposite, or the adjacent, which is x, over the hypotenuse, which is 23. Slap that over 1, and then we can just cross multiply this. So x times 1 is x. 23 times cosine 37 goes in your calculator. So 23 cosine 37. So if we're rounding this to the nearest foot, we're going to say it's about 18 feet if you care to put the units. Okay, next, the staircase is 60 feet long, and it makes an angle of 38 degrees with the ground. So we've got stairs. So our stairs are going to be the diagonal. So it's got stairs that are 60 feet long, and we've got our right angle over here. It says it forms an angle with the ground. The ground is the bottom, so it's got to form the angle over here, because we already know the other one is 90. So again, it says how high is this guy? So if I set up my trig ratios again, like we did on the last problem, this is the hypotenuse, this is the opposite, and this is the adjacent. So when I do my SOHCAHTOA, I have to get rid of anything that uses the adjacent side. So I don't need cosine or tangent. So that means I'm going to have the sine of 38 equal to the opposite over the hypotenuse. Put this over 1, cross multiply. So x equals 60 times the sine of 38. So I'll go in the calculator, 60 times the sine of 38. Round into the nearest whole number. Is this whole number again? And it doesn't say, but I'm going to say that we're going to round it again. So we're going to say it's just 37 feet. Okay. Next one says convert each degree measure to radians and each radian measure to degrees. So in order to do this stuff, you have to remember a couple formulas. So let's say we're going radians to degrees. If we have a radian has a pi, and the degree has the degree symbol. So that means that on this type of problem, we have to take it times 180 over pi. So that way the pi's cross out. If we have degrees to radians, remember the radian has the pi, the degree doesn't. It's got the little symbol for degree. So that means we need to give it the pi. So that means pi goes on top and then 180 goes at the bottom. So to convert this, we want to turn it from degree to radian. So we're going to have to times it by pi over 180. And then you can just put that in the calculator. So pi is, let's see, let's do 130 first. So we got 130, if my buttons work, times the fraction, pi is shift exp, and then 180. So that would be 13/18 pi. 40, same thing, we need it in radians, so we're going to put pi over 180. So 40 times pi shift exp over 180. So that's 2/9 pi, or 2 pi ninths. Next one is 320, so times pi over 180. So 320 times shift exp over 180. That's 16 pi ninths. Next one is 215 times pi over 180. That one is 43 over 36 with a pi on it, times pi over 180. Forgot 43 over 36. Okay. Now, the next couple of questions, they have pi on them already. So to get rid of the pi has to go down at the bottom this time. So I'm just going to write that for both of them so I can save some time here. And now just type it in the calculator. So fraction 7 over 12 shift exp. Oops. We want to make sure to put that pi off to the side and not at the bottom. Times 180.
I didn't understand that.
Be quiet. Sorry, my phone's talking to me. And then pi again. So that's 105 degrees. Next, 19 over 18 shift pi, and then times 180 shift, oh, not shift yet, I got to put the fraction first and then shift exp. So that's 190 degrees. Okay, now for the following, draw the angle with the given measure in standard position. So the way we do this is we break the graph into 90-degree segments. So we know this right here is 90 degrees. So 100 degrees is going to have to go just past that. So this is my initial side, and my estimate would be about right here. Now we have to show people which direction we went because there's actually two angles in this picture. So we show positive going this way. Okay, next, 500 degrees. Now, anytime we have a number that's over 360, we have to graph the coterminal. So I'm going to subtract 360. So I'm going to take 500 and subtract 360. So it should be the same measurement as 140. So 140. So let's see what we got here. This graph has 90 degrees here, and then it's got 180 degrees here. So if I wanted to graph 140, 140 would be 50 more degrees past 90. Now halfway between 90 and 180 is 45 degrees, so I need to go just past halfways. And I need to show everyone I went this way. Okay. Next one is 8 pi ninths. Now again, a lot of people have problems with fractions, so I'm just going to convert this really quick. over pi. So let me type that in. So 8 over 9 shift pi times 180 over pi shift exp. So we're graphing this actually is 160 degrees. So we know this is 90 and this is 180. So that means that we have to be 20 degrees off of 180. So we'll go about right here and show that we went in the positive direction. Okay, next one, 11 pi ninths. Again, I'm going to times this by 180 over pi. So let's go in the calculator, clear all this stuff. So 11 over 9, over 9, shift pi times 180 over pi. So we got to graph 220. So if I want to graph 220, this is 90, this is 180, and this is 270, so it has to be in that third quadrant somewhere. So we need to see how much further past 80 we need to go. So that would be another 40 past 80. So 45 is right in the middle, so we're going to go right before the middle. And we're going to come like this because it's positive. Next one is 270, so here's 90, here's 180, and here's 270. So we're just going to go all the way to here. So our graph, I should be drawing the other initial side also. My bad if I didn't. It should be like this. So we got the initial side, then we've got the terminal side. You should always show both of them. Okay, next says find the reference angle for each angle given. If the degree is, if given degrees, it has to be in degrees. Likewise, if it's given in radians, it must be in radians. So we got to draw the picture to figure this out, kind of like a puzzle. So this is 90, this is 180. So 130 has to be somewhere in here. So when we draw 130, 130 is going to be 40 degrees past 90. So I'll mark this right here as 40. So the reference angle is going to be the other side, back to the x-axis. So it's going to be this measurement here. So if I went 40, that means this one has to be 50, because in a graph paper, every quadrant is 90 degrees. So all we have to do is break them up into those chunks, and then we can figure it out. So this right here is our answer. Okay, next, 40 degrees. We know this is 90, and this is 0. So 40 degrees would have to be just before halfways, like this. Oops, that's too low. Maybe a little bit higher like this. This would be 40. And the thing about the first quadrant is your reference angle is going to be the same exact measurement. So that's our answer. That's the reference angle. It's always the distance between the terminal side back to the initial side, the x-axis. Not the initial side, just back to the x-axis that's closest to it. Okay, next, got to draw out 320. So this is 90, this is 180, this is 270. So this is 0, but it's also 360. So 320 is going to have to be over here. So it looks like it's going to be, what's that, 70, 80, 90, 100, 10, 20, 50 degrees past, oops. I've got to go 50 degrees past 270. So 45 is almost halfway. So this would be 50. That means this part right here would have to be 40, and that's our answer, because our terminal, our reference angle is always terminal side back to the x-axis using the shortest path. Okay, 215 degrees. Draw this one out. This is 90. This is 0. This is 180. And then we've got 270. So it's got to be in between 180 and 270. So how much further is 215 past 180? If you're not good at doing it in your head, you can always just subtract this. So we're going to do minus 180. So it's 35 degrees past. So we'll say this is 35. Now the reference angle is going to be this guy back to the x-axis. So it's 35 degrees. So once we start getting into problems that have pi's in them, we're going to convert them so that way they make a little bit more sense in how to graph them. So I'm going to times this to, what is it, 180 over pi. So let's make it make sense. So 7 over 12 pi times 180 over pi. Oops, shift and then exp. So this is really saying to graph 105. Okay, that's not too bad. If I want to graph 105, this is 90. So 105, 10 more would be 100. So about 15 more would be 105. So if that's 15, 90 take away 15 is going to be 75. So this side over here is 75. That's our answer. Oh, I almost forgot. I got to convert it back. They don't want it in degrees. They want it back in radians. So we're just going to multiply this with the pi and 180. So we're going to put 75 times shift exp over 180. So the answer they want is 5/12 pi, or 5 pi 12, however you want to say it. Okay, so it says give two positive coterminal angles for the given problems. If the problem's in degrees, do it in degrees. If the problem's in radians, do it in radians. So these ones should be pretty easy. It's all calculator work. So all we're going to have to do here, a coterminal angle means that it ends up at the same spot. So the way you get it to end up at the same spot is you get it to go all the way around. So basically, you're either going to add 360 or you're going to subtract 360. It just depends on how you want to do it. Now, if it's in pi, you want to add 2 pi because a full circle around is 2 pi, or you want to subtract 2 pi. So if I have 100 degrees and I add 360, one of the coterminals is going to be 460. And then if I take 460 and add another 360, that's going to be 820. So those are our measurements. 500. So if I want, I can do 500 plus, oops, not times, plus 360. That'll definitely give us a positive, so 860. And I'm noticing this guy right here is above 360. So if I wanted to come up with a positive answer, I could also do minus 360. So another one could be 140. And again, guys, this list is infinite. You can just keep adding 360, 360. But the thing is, right here, they want it positive. So that's why I'm not going to subtract 360 2 times in a row. Okay, if it's in terms of pi, we just want to add 2 pi. Because a full circle, full revolution, would just be 2 pi. So I'm going to add 2 shift pi. So this would be 26 pi ninths. And then I'm just going to plus 2 pi again, shift 2 pi. And that's 44 pi ninths. 44 pi over 9. 11 pi ninths. Not alpha, shift pi over 9. Oops, over 9 I said. And we're going to plus 2 pi, shift exp with the 2 in front. That's going to be 29 pi ninths. If I just do that one more time, plus 2 pi, that's 47 pi ninths. Okay, this one's back in degrees, so we're going to do the 360 again. So 270. I'm going to add 360 because if I subtract, that would be negative, and that's not good. So 630. Then I'm just going to add 360 to that again. So that one is going to be 990. Pretty simple. Okay, next, they want us to fill this out. And guys, this is a straight up memorized question. This exact question is on the test, so you just kind of have to memorize a sentence. This one says, all students take calculus. And so this one is going to tell us which signs are positive. So in this one, every sign is a positive. In the second quadrant, only the sine is positive. In the third quadrant, the tangent is positive. And then in the fourth quadrant, the cosine is positive. So this is all students take calculus, and all means all three of these have to be positive. Students is sine, take is tangent, and then calculus stands for cosine. So that basically means that everything else is a minus. Simple. Okay, so with that being said, now we have to draw our own picture and take into account how the quadrant is going to affect the signs of our answers. So let's draw this in quadrant 4. So I want to draw my triangle in quadrant 4. Quadrant 4 is this guy right here. Now they gave us some information, and they gave us two numbers. So let me write down SOHCAHTOA real quick. SOHCAHTOA. They're giving us the cosine, so this means that this is the adjacent side, and that means this is the hypotenuse. So when I label this based off of this corner right here, because theta is always in that corner closest to the origin, the adjacent side is going to be the x-axis. The adjacent side is always the x-axis. And then the hypotenuse is 4. So in order to find the tangent, we have to first find the missing side. And we can do this by doing a squared plus b squared equals c squared. So when we do a squared and b squared, we have to use the two sides that are forming the 90-degree angle. So the legs have to be added together. So it's going to be x squared plus 1 squared equals 4 squared. So this would be x squared plus 1 equals 16. Then I would subtract 1 from both sides and get x squared equals 15. Then I would square root this and square root this. So x equals square root 15. Now you have to be real careful. That square root of 15 has to go here. And because we're in the fourth quadrant, this goes down. And down represents a negative. So that, let me scoot this over. That's not what I wanted to do. I wanted to do this. So because this triangle is drawn by going down, that means that one measurement has to be a negative. We know also this guy over here has to be a positive because that's on the right side of the x-axis. And this guy right here, this is below the x-axis. So that's the reason why this one right here is a negative. So now the real problem is find the tangent. So we did all of that work to say that the tangent of theta is going to be the opposite over the adjacent. So the opposite side is the side that we just found, so negative radical 15. And the adjacent side is the x-axis, so negative radical 15 over 1, which is equal to negative radical 15. And anytime you're doing these problems with fractions, you should always type them in the calculator. I was able to simplify that one because anything over 1 is just the top. So that was pretty easy. Okay, same thing, quadrant 3 this time though. So in quadrant 3, our triangle would go like this. And let me write down my SOHCAHTOA. Oops, let's write that bigger. SOHCAHTOA. So if I'm labeling this and we're doing the sine, here's my theta. This sine right here, they gave us two numbers. The sine is going to be the opposite over the hypotenuse. That's how you do the sine. So the opposite side has to be 3. So this is my 3. And the hypotenuse has to be 5. Now here's the thing about this problem. It does have this extra negative right here. So we have to decide where it goes. Because we're in the third quadrant, your sine and your cosine, which means your x and your y value, is negative. So that means this answer right here is negative. So now that we have that, we can go and do a squared plus b squared equals c squared. So I'm going to put x right here because we don't know what that is yet. So I'm going to have x squared plus negative 3 squared, and make sure you use parentheses anytime there's a negative, equals 5 squared. So you have x squared plus 9 equals 25. And then you subtract 9 and subtract 9. So you get x squared equals 16. You square root, and you get x equals 4. Now our math says that the answer to that missing side is 4, However, the quadrant that we're in, because we're going to the left, means this has to be a -4. So now the real problem is to set up the cosine. Your cosine is going to be cosine of theta is equal to the adjacent over the hypotenuse. So the adjacent side is always the x-axis, and the hypotenuse is the diagonal. So that's going to be 5. That's our answer. Okay, this next one, this is just something you can memorize if you want to, but you don't really have to. So the measurement in degrees, this is how easy this is. That's 0. Halfway would be 90. And then the middle of this is going to be 45. And everything else, you just count by 30s. So this is 0, so that makes this one 30. And then that makes this guy, what is that, 60. Yeah. And then when you do your radians have pi's on them, so this would just be 0 pi. And then what are we doing here? Oh, we're doing our pi's. So I guess we could do over here, this is going to be pi halves. Pi halves, there we go. And you can do all of your conversion using the calculator and all that stuff. So what else do we have here? If I want to do my conversions, let's do 60. I want it to have a pi. So I'm going to hit times shift pi over 180. So 60 degrees is going to be the same as pi thirds. So this one right here is pi over 3. And then this guy right here, if I do the same thing but with 45 times shift, let's put in the pi over 180. That's pi fourths. And then the last one is going to be 30 shift pi, oops, times pi over 180. And that's pi sixth. Now there's a cool trick. It's like kind of like the when you multiply by 9s. So let's say, well, we should know this one already. This is 1, 0, and this one over here is 0, 1. So let's say you have your hand. So I'm just going to draw a stick figure hand. 1, 2, 3, 4, 5. Okay. So you have to imagine these 3 fingers represent the 3 fingers here in the middle. So not including your thumb and your pinky. So when you go to this first line, if you were to hold this first line down, this guy right here is going to show us the cosine and the sine. So because I have 3 fingers, we're going to put radical 3, and it's always over 2. Every single one of these problems is always over 2. And then this guy right here, this is just 1, so this is going to be 1/2, because square root of 1 is just 1. And that trick works like every single time. So let me show you that again. Here's your thumb, pointer, middle, ring, pinky. So if I want to do the second, this would be your middle finger. So you would hold this one down. So that means that each fraction is going to have a 2 on the top. So I've got 2 here and 2 there. So we would put it inside of a radical 2 and radical 2. And then these are always just over 2 every single time. Okay, I'll show you that one last time with the fingers. So thumb, middle finger, no, that's not your middle, that's your middle, there's your ring, and then there's your pinky. So if we're doing this line now, that means we're going to put down this finger. So the first one has to have a 1, so this is radical 1, which is just 1 over 2. And then the other one has 3, so this is going to be radical 3 over 2. Now this chart on the review is kind of pointless because your test has the full unit circle. But now that we have it filled out, now we could just quickly answer some of these questions over here. So the sine of 60, remember the cosine basically represents the x and the sine represents the y. I don't know why I put this right here. So when they're saying for the sine of 60, they want you to go to 60 degrees and tell me the second number. So this is radical 3 over 2. Now, in the event that you get past 360 degrees, like in this picture here, this is way too far. So we're going to have to subtract 2 pi. So if I subtract 2 pi from this, that's supposed to be a pi, this is going to be 1 pi. And 1 pi, if I had the actual unit circle, 1 pi is halfways. So it'd be this line over here. And again, the sine is the second value, so the y value over here would have been 0. Cosine of 2 pi thirds. So 2 pi thirds, cosine of 2 pi thirds. Let me go ahead and steal one of these guys, since you're going to be able to use it on the test anyways. Make a copy of that and bring it over. So let's put this guy, let's paste it in. If maybe I can, I don't know. Let's go back over here. I'll make a clone of this guy. There we go. And then I will cut it. And I don't know how to paste. Anyways, let's just go off the chart. So we'll go off 2/3. So 2 pi thirds, and we want, again, what is that? The cosine of 2 pi thirds. So in this picture, 2 pi thirds is here. The cosine would be the first number, so it's negative 1/2. So this would be negative 1/2. 7 pi fourths. 7 pi fourths. Where are we? 7 pi fourths is right here. And that question wanted the cosine. So the cosine is going to be your first number. So that's radical 2 over 2. So radical 2 over 2 was the answer for this guy. This one is above 360, so I need to subtract 360. So that's going to be 120. So I need the cosine of 120. Cosine of 120, 120 degrees is here. The cosine is the first number, so that's negative 1/2. Oops, I put down the wrong one. Negative 1/2. 7 pi fourths. 7 pi fourths is this guy right here. And I believe they wanted the sine. Sine is the second number, so it's negative radical 2 over 2. Sine of 570, that one is too big. It can't be higher than 360. So I got to subtract 360. If there's ever a time where you don't see it on the chart, you just either subtract 360 or subtract 2 pi. So this problem right here, let's get this out of here. This guy right here is going to be, what, 120 degrees? No, that's a lie. It's going to be 570 minus 360. 0, 1, that's 210. So I got to go to my chart and go look at 210. So 210 degrees is right here. I forgot what they were asking us for. The sine is the second number. So 210, second number. Oops, that's the wrong one. It's going to be at negative 1/2. Negative 1/2. Okay, so this one is asking us for what value of pi. So that basically means where. Where in radians does the cosine equal 0? So remember, cosine is the same as x, and sine is the same as y. So when they're asking us for the cosine, they're asking us for the first number. And this right here means go around the whole circle. So we want to know everywhere in the circle where the cosine is 0. So that's the number in the first spot. So the first spot is 0 here. So it's at pi halves, and the first spot is 0 here at 3 pi halves. And they want it in radians. This right here means it has to have a pi on it. So our two answers, the locations are at pi halves and also at 3 pi halves. I'll show that to you again because I know that was a little confusing. Okay, so this one says find all of the places where the sine is negative radical 2 over 2. So remember, the sine is the same as the y value, and the y value in a point is going to be the second spot. So we need to go around the whole circle and find anywhere where the second spot has a negative radical 2 over 2. So if I start at 0 and just work my way around and looking in those parentheses, the first negative radical 2 over 2 I have is right here, so that's at 5 pi fourths. and I keep going around this circle, and the second negative radical 2 over 2 is right here at 7 pi fourths. Okay, knowing that the cosine of pi 6 is 3 radical 3 over 2, fill in the blanks to create another trig equation in radians from the same quadrant. So first of all, I got to know where pi 6 is. Pi 6 is right here, and that number is radical 3 over 2. So they're saying it has to be in the same quadrant. So I need to stay in between here, and I need to make another problem that's going to have an answer of radical 3 over 2. So as I search through these parentheses, there's only one other radical 3 over 2. And that location is this guy right here. So this is going to be pi thirds. And because it's in the second spot, we're going to say it's got to be the sign at pi thirds. Okay, and I'll show you that to you again, obviously. So this one right here, it says, knowing that 3 pi fourths, here's 3 pi fourths. 3 pi fourths is right here. The 3 pi fourths is, for the sign, is this number here. It says, create another trig equation in radians. Now this one says from any quadrant. So we can write any problem as long as the parentheses has a positive radical 2 over 2. So there's a lot of different answers you could do for this one. So if I go around my circle and I just go try to find all of my positive radical 2 over 2's, here's one. So I could write the cosine at pi fourths. So the cosine at pi fourths is radical 2 over 2. Another one I could do, let's get rid of that. Another one that I could do, I'll do a few. So I need another radical 2 over 2 positive. So here's another one here. So another one I could say is the sign at pi fourths. That's equal to radical 2 over 2. And it doesn't have to just be in that quadrant. It could be anywhere. So if I go, let's clear all this stuff out. I just need a radical 2 over 2. So here's another one right here. It's the second spot. So that's going to be the sign at 3 pi fourths is equal to radical 2 over 2. And then if I go find another positive radical 2 over 2, I think there's one more. And yeah, it's right here. My pen worked. So I don't know what's happening here. My pen completely died. So I'll just have to use my finger, I think. So positive radical 2 over 2 is right here. So that's the first number. So that would be the cosine of 7 pi fourths equals radical 2 over 2. You didn't have to do every single one. You just had to come up with one of them. Okay, so now identify the ordered pair that occurs at the terminal side of 360. Remember that, or not 360, 390. Remember, anything higher than 360, we have to subtract 360 and find the coterminal. So they're asking us for the pair at 30 degrees. The pair at 30 degrees is going to be radical 3 over 2, comma, 1/2. Okay, next, identify the ordered pair that occurs at the terminal side of 570. So again, I got to subtract 360. So if I subtract 360, that's going to give me 210. So 210 is here, and they want the entire pair, so it's negative radical 3 over 2, comma, negative 1/2. Okay, now the review. Given the function, when is it increasing? So you kind of have to look at the graph for this one. So if I was looking at the graph, I could go into menu. I could hit up the graph. Let's get rid of that guy, and I'll put 2x minus 8. And that picture looks like a line, and that line is headed like this. So if we read the graph from left to right, this graph is always heading in the upward direction. So this guy is going to be increasing from negative infinity to infinity. That means that it's always increasing and it's never going down. Okay, solve for x. This one, they were very generous to us because they're already in parentheses, so we can just set each parentheses equal to 0 and solve. So I'll have to add 4 and add 4 here. So I'll have x squared equals 4. Then I'll take the square root, and I get x equals plus or minus 2. Then I subtract 6 from both sides, and I get x equals minus 6. So again, this has to have 3 answers because 2 of them are right there in the squared, and then you have the other one right there. So there has to be a total of 3 answers. Last one is solve for x, so we're going to cross multiply this bad boy. So 3 times 4x plus 2 equals 6 times 2. So we'll distribute that. So that's 12x plus 6 equals 12. Subtract 6 from both sides. So we get 6. So cross out. Equals 12x. Divide by 12. And be careful here, guys. Anytime that bottom number is bigger, your answer is going to be a fraction. Always double check fractions in the calculator. Okay, so that was it. That was a review. So that was a longer one, but yeah, a lot of it's pretty quick. You read it off the unit circle. So hopefully that helps you do better on this last test of the semester. Psych, it's not the last test. We have one more test after it. Sorry.